Alright, let's learn how to solve absolute value equations. And the first thing we use absolute value for is to find the distance between two numbers. So if A and B are real numbers, that means they're on the real number line, then the distance between A and B is the absolute value of their difference. So we're going to subtract them and then take the absolute value. And the cool thing about it is that it doesn't matter which one I subtract from which. I can do A minus B or B minus A. So find the distance between -5 on the real number line. We're going to do absolute value of -5 minus 9, which is the absolute value of -14, which is 14. Or we could do the absolute value of 9 minus -5, which ends up giving us the absolute value of 9 plus 5, which is 14 again. So what that means is that if we were on a number line and I had a point at -5 and I had a point at +9, then the distance between those points would be 14 units. Okay, and now let's talk about how we can solve absolute value equations. So we're going to solve this absolute value equation algebraically and graphically. So we're going to use our calculator on it. Here we go. Here's the algebraic. Since an absolute value inside can be either positive or negative, we're going to do two cases. We're going to do the positive case and we're going to do the negative case. And I go ahead and solve these like normal. So I'm going to add 3 to both sides. X is 11. And I'm going to add 3 here, and X is -5. So both of these will work. X is either 11 or -5. And now let's solve it graphically using our calculator. So I'm going to go to Math and then over to Numerical to get our absolute value function. So there's ABS. And I'm just going to type in X minus 3. Then I'm going to arrow down to Y2 and I'm going to make that equal to 8. Then I'll hit zoom 6 and there's the absolute value. And there's Y equals 8. And you're going to see I need to get a little bit more. So let's change our window to go from -10 to 15, do a scale of 5, and there's the absolute value. There's the Y equals 8. I'm going to go second calc, and we're going to get the intersection. So there's my first curve, enter, second curve, enter, and then I'm going to guess, okay, I'm going to put in -3. And the intersection right there you can see is at -5, 8. And then you do the same thing to get the other intersection. And that other intersection would be, of course, at 11, 8. Okay? So this one here is at -5, 8, and there's 11, 8. Alright, so here we have absolute values on either side, and they're the same one, the absolute value of x minus 1. So I'm going to add 4 of them to both sides. So I've got 2 plus the absolute value of x minus 1 equals, that's a 1, equals 7. Subtract 2, the absolute value of x minus 1 equals 5, and then we go with our positive and negative case. So x equals 4, and here x equals, well, not 4, x equals 6, right? X equals 6, and here x equals -4. So we have two answers, -4 and 6. All right, let's take a look at this. So we have 1 minus 3x equals -7, and 1 minus 3x equals +7. And we get -3x equals -8. So x is 8/3, and -3x equals 6. So x equals -2. However, the answer is no solution. And why is that? Because you can't have an absolute value equal to a negative number. So watch out for that. That's a tricky question. Okay, so now let's talk about absolute values and inequalities. So we're going to do a positive and negative case, but remember that when we do a negative with an inequality, we have to switch the direction. So it's going to be greater than or equal to negative 7, and 3x minus 2 is less than or equal to 7. And we go ahead and solve this like normal. So I'm going to add 2 to both sides. And over here I'm going to add 2. And I get x is greater than or equal to negative 5/3, and x is less than or equal to 3. So on a number line, negative 5/3 with a bracket, positive 3 with a bracket, and x is greater than negative 5/3 and less than 3. So it's everything in between. In interval notation, that would be negative 5/3 to 3 inclusive. Okay, let's try this one. So I'm going to go 1 minus 2x is less than negative 5, and 1 minus 2x is greater than positive 5. So negative 2x is less than negative 6. I'm dividing by a negative, so I'm going to switch the inequality, and I get positive 3. Over here, negative 2x is greater than 4. Switch the inequality. X is less than negative 2. On a number line, I've got a parentheses at negative 2 and a parentheses at positive 3. X is less than negative 2, so it's everything that way, and x is greater than 3. So let's take a look at the two different answers we got. When we had an absolute value that was less than a number, we get everything shaded in between. And when we have an absolute value that is greater than a number, we have the shading going in opposite directions. This is called a disjunction, and this is called a conjunction. Okay, one last tricky question here. Solve the inequality. Absolute value of 2x minus 3 is greater than negative 8. This is all real numbers because any absolute value is automatically more than any negative number.